Hello, everyone. Today we're going to start chapter 11. We just finished up chapter 8, but we're skipping to chapter 11. So we're going to do 11.1 and 11.2, and that should take us to June 5th. 11.1 we're going to do in 2 videos. 11.2 we will do in 1 video. Before you start today, you need to have your graphing calculator. You need to have your notes for this section. And you need to have something called a chi-square chart. If you go to chapter 11 and it says blank copies of all notes and chart, it will be there. It looks like this. It's your third and final chart. It looks like the T, but it is not a normal curve. So before you start, you may want to pause this video and make sure you have the notes. If you want them, you don't need the notes, but it would be best if you printed out a chi-square chart. If not, you can just use, there's one in your book, and you can kind of just use the one online too that I have posted. So either way, and your graphing calculator. You need your graphing calculator. Okay, so we're going to do something called Test for Goodness of Fit today. We are going into what's called categorical data from now on in this whole chapter. So categorical data is not like a list of data where you're doing means and I asked you like how much you weigh, and I get a list of data in list 1 and I get all these pounds and then I average it out. This is something different. So this is categories, like I'm going to look at my class and I'm going to look at their eye color. How many people have brown? How many people have green? How many people have blue eyes or something like that? Okay, so these are categories. So all of your data is going to be in categories. This test for goodness of fit is a test to see how good your data fits to what we expect. Right? So there are 2 different types, and yes, goodness is a word. And this is an actual name of a test. So there are 2 types. There are where your data is evenly distributed, and that's what we're going to do today. And then part 2 of the video, what you're going to do is this type where we'll talk about percent. So let's just talk about the evenly distributed. So you have a theory that in a store, they sell the same amount of each color of t-shirt. So you walk into a store and let's say it's Hollister, and you're looking at these t-shirts, and there's these t-shirts for your brother, and there's a white, a blue, a red, and a black. And your theory is that they sell the same amount of each color, right? So that would be an evenly distributed one. You would take and look at all the total shirts that were sold and divide them by how many categories you have to see if there was the same amount. So what we're doing is testing to see how good our data fits to what we expect. Okay, so here's what the chi-square chart looks like. The chi-square has no negatives. It starts at 0 and then just gets bigger. All right, so it just increases. Here is the formula for the entire chapter. And let's see what we're doing in this formula. So we're taking what we observed, how many of each t-shirt, let's say we bought, and minus what we expected every number to be in these t-shirts, squaring it and dividing it. Okay, so here's what will happen. If my observed, what I actually sold in each color, and my expected are the same, then this is going to go to 0. That means when I get a test value, this is going to be my test value, like in my hypothesis test. Okay, if I get a test value of 0, that means my observed and my expected fit exactly. So how good did they fit? Pretty good, dead on. So if you get a test value of 0, they fit dead on, okay? So the further this away you get from 0, the bigger this number gets, okay? Like let's say if you get a 30, that means your data did not fit well at all. The difference between what you observed and what you expected was way off. So where do you start rejecting? You're going to start rejecting out here. In this whole entire chapter, it's always a right tail test. So you don't have to worry about less thans, greater thans, not equal to. The hos and the ha's are going to be in sentences. All right, so you are measuring how far basically your observed and expected are from 0. It is a right skewed, remember right skew the tails to the right. That was kind of a bad one. You can see it better on the chart. But anyway, so you're always doing a right tail test. Don't have to worry about less than, greater than. If you're a perfect matcher at 0, maybe here you're a little off, here even more off. Here's where your critical value is going to be, and we're going to get it from that chi-square chart. And this is where you're going to start rejecting. This is where you're going to say that my observed and expected are so far off that something's wrong with it, that they're not going to be evenly distributed. Okay, so today's an evenly distributed one. All right, so today we're going to do the evenly distributed, and like I said, part 2 of the video, we'll come back and do these percents, so just kind of ignore that percent stuff for right now. Okay, degrees of freedom in this, still DF, still doing DF, but it is how many categories, not how many things, but how many categories minus 1. So we're going to have these categories, like the categories of t-shirt color. To do this on your calculator, there's 2 different methods. If you have an 84, it is super easy. If you have an 84, so if you have a TI 84, you're just going to go to stat tests where we've been going, and you're going to go down to something called a chi-square Goff test. If you have an 83, you do not have this test. Suggestions: borrow an 84, or I'll do it the 83 method. It's just kind of a long and drawn out. But if you have an 84, get it. Also, I was told that you will be able to download an 84 onto your school Chromebooks, that they were pushing those out. I'm not sure how. It's kind of, we were told that, but I don't know if you've been allowed to do it yet. So if you can get an 84, get an 84. If not, then I will show you how to do the 83. So super easy. If you have an 84, all you have to do is put what we observed, you're going to be given that, in list 1. Then we're going to calculate an expected list, what we expected, and we're going to put that in list 2. If you have an 84, all you have to do, the only work you have to do is put the observed, which are given in list 1, calculate the expected, and run this test. It will give you everything you need. Okay. If you have an 83, so this is 83 people. I have this big red, you have a TI 83. This big red box around here. You are going to have to do all of this stuff. So you're still going to have to do list 1 and list 2, but then you're going to have to do all of this. I will explain all of it to you as we go through the process. Basically, you're going to have to calculate observed minus expected. That would be list 1, list 2, squared divided by expected. You have to calculate the formula on your own. You have to sum it up, and then you're going to find the p-value using this function. If you look up here, here is the formula, O minus E squared. Okay, let me clean that up a little bit. Okay, you are going to have to put it in your list, and you're going to have to do list 1 minus list 2 squared divided by list 2. You're going to do that in list 3. Then you're going to sum it up, and I'll go through it with you. 84 people, super easy. All right, here we go. Example 1. Is there enough evidence to reject a claim that there is no preference in the selection of fruit flavor sodas using the data below? So I didn't put the whole paragraph in here, but basically they did a taste test. And let's say it's for different flavors of like those waters, like, oh gosh, what is those waters called? I can't remember what those waters called, but whatever. So there are different flavors of water. So we have 5 different flavors. So we have 5 categories, and we want to see if there is a preference or if there's no preference in the selection. All right, so the ho and the hot in this chapter are going to be sentences. I told you it's always a right tail test. So just remember that ho goes with no in this whole chapter. So ho goes with no, meaning that there's no difference in these categories. Right? So I'm going to create a text box to type this up. So ho goes with no. So ho and you're going to say no preference in the selection of soda flavors. Okay. Or you could also say the flavors of soda are evenly distributed. Right, so either one. So if there's no preference in soda flavors, then that means that each one of these flavors should be evenly distributed. The ha is going to be there is a preference. They're just opposites. So remember, ho goes with no, that nothing is going on between the categories. So there is a preference in the selection of soda flavors. Or if you're going to do the other one, you would say the flavors of soda are not evenly distributed. Okay, so either one. If you say no preference, then in the ha you say there is a preference. If you say the flavors are evenly distributed, then you say the flavors are not. Just kind of keep it consistent when you're doing it. Oop. Alrighty. Next step. So we have our ho and ha. So our next step is to do our critical value and shading. Remember, there's no negatives in chi-square, and it kind of looks like a right tail test. I mean, it's a right skewed, so it's a right tail test. So we have an alpha of 5%, remember from last chapter, and every chapter is the same. Your alpha level is your total shaded. Okay, degrees of freedom. Degrees of freedom is categories minus 1. So we have 1, 2, 3, 4, 5 categories. Minus 1. So our degrees of freedom is 4. We're going to go to the chi-square chart, and we're going to go up at the top. Don't worry about dividing alphas or anything. It's super easy. See, that's a better drawing there. We're going to go to 5% and down to 4. 5 categories. It's going to be at categories minus 1 on this section. So you're going to go to 4 and 5. And we get 9.49. So your shading starts at 9.49. Okay, there you go. So that's that. Now we're going to go to the calculator. So get your calculator out, and you are going to take and you are going to put in list 1 your observed. Okay, so in list 1 goes your observed. Your expected is going to go in list 2. So let's talk about this. If you total up list 1, the total amount of people that tried the soda flavors was 100. I just totaled up list 1. Now, if they were evenly distributed, then that means that these should be all of the same. If there was no preference in the flavor, if there was no preference between grape and lime, they should have the same amount of people. So your expected in this problem, you have to think this through every single time, is 100 people divided by 5 categories. So your expected is 20. You expect 20 people to like each flavor. Why? Because that will tell me that there's no preference in the flavors of the soda, or that they're evenly distributed. So I'm just evenly distributing it out, 100 people divided by 5. Okay, so I took my total and divided by my categories. This is going to go in list 1. This is going to go in list 2. That's everybody. So stat, edit, in list 1 and then in list 2. Ignore that list 5 for right now. So I'm going to go up to list 2, and I'm going to just put 20 in each one. Oop. Okay, so in list 1 is what I got, my observed. List 2 is what I expected. If you have an 84, this is where it becomes super easy. So 84 people, all you have to do is go to stat, tests, and then down here's a Goff test. Okay, we don't want the C one. We don't want this. We want the Goff for goodness of fit. So you want the one that says goodness of fit. Everyone has this. So if you have an 83 and you think, oh, I have it, you don't. You want the one that says Goff right now. This is the second section in this chapter that we'll be doing where everybody has. Like I said, only 84 people have this. So go into it. And all you have to do is say, my observed is in list 1, my expected is in list 2, and my degrees of freedom was 4. I had 5 categories. 5 minus 1 is 4. Hit calculate. And we have several things. There's our test value. There's our p-value. And then this right here, you need to, this is the work for the formula. So this is O minus E squared divided by E. O minus E squared divided by E. O minus E squared divided by E. So if you have an 84, you have to write down, just to show work, the first 2, ... and then the last one. And that adds up to 18. And then there's your p-value. So if you have an 84, you're pretty good to go. Okay, just hold on a minute. So if you have an 84, either fast forward for a second or just write this stuff down and then we'll talk about it in a minute. All right, 83 people. You have to go to Stat, Edit, into your calculator, and you're going to have to do the formula, the O minus E squared divided by E, in your list. So you're going to go parenthesis. O is list 1 minus E is list 2, parenthesis, squared, divided by list 2. Okay, now let's look at this. The formula for chi-square is O minus E squared divided by E. So you're going to go up to the top of list 3. Make sure you're here, not here. Make sure you're here. And you're going to hit O minus E squared divided by E. All right, so once you hit that, okay, 84 people, this is what you had in that bracket that said contributions. This is the contributions to the test value. So let's everybody take a minute here and look. The one that contributed most to the test value was this first flavor. I think it was cherry. You had 32 people that liked it, but only expected 20. So that one contributed most to the test statistic, we're going to say. The one that contributed the least was 16, which was orange. 16 people liked it, and you expected 20. Another one that was way off was this one down here, which is grape. Not a lot of people liked it, and you expected twice as much. So these two contributed the most to the test statistic. All right, 83 people, still not done. You have to sum this up. So we're going to do just stat. Oh, sorry, excuse me. Second stat to do sum. Remember, second stat is your sum function. Hold on a minute. Math, so second stat, math, sum, and you need to sum up. Oh, I'm still in the list. Shoot, I had to quit out. Sorry about that. Second stat, math, sum. So second stat, math, sum. Just your sum function you've been doing. Second, and tell it to sum up list 3, and we'll get that 18. Okay, so 84 people, this is all done for you, like I said. So you get 18. Now we need to find a p-value. Okay, so 83 people. Ready? I have this all written on the front of your thing. I'll show you again. So second, bars, and you're going to go down to number 8, this chi-square CDF. Okay, your 18 is your test value, and then you're going to go to infinity. Just one with a whole bunch of zeros. Just hit a one with a whole bunch of zeros. That's infinity. The degrees of freedom was 4 because we had 5 categories. We hit paste. And there is your p-value. All right, so if you have an 84, all of this is done for you. All you have to do is put it in list 1 and list 2. All right, 83 people. I'll go back over that in a second. All right, so let's go back to the notes here. All right, so everyone, no matter who you are, has to write down the test value and has to write some of the work. So the rules in STAT is you have to write the first 2 and the last one. So you can do 7.2, 83 people, this is the first thing in your list 3. 84 people, this is in those brackets. These are the numbers in the brackets. So 7.2 plus 3.2 plus ... and then the last one was 5 equals 18. That's your test value. Okay, where does this come from? This comes from O, which was cherry, 32 people, minus, we expected 20 squared over 20. That's where that comes from. Plus, the second one is 28 minus 20 squared over 20. Plus, the last person was the grape. Remember, the grape was bad. Only 10 people liked grape. O minus E squared divided by 20. That adds up to 18. Now, you have to show work. I don't really care. You can either show this or this. You don't have to show both. So if you have an 83, this is list 3. If you have an 84, those are the brackets. Okay. So 84 people. We go into STAT tests again. You have an 84. It's super easy. You go to Goff test, go in. You just put your data in list 1, list 2, degrees of freedom 4, calculate, you're good to go. There's your answer. There's your p-value. There's what I was talking about. This is list 3 for the 83 people. So you just have to do 7.2 plus 3.2 plus ... and then the last one. So first 2, last 1 for work. If you have an 83, then you are going to go. I'm going to do this again for you one more time. If you have an 83, you're going to go up to the top of list 3 and you have to type in the formula, parenthesis, O minus E, parenthesis, squared, divided by E. Before you hit enter, make sure 2 things, 83 people, that you have exactly what I have typed and that you're up here, not here, or you'll get an error. When you hit enter, you should get the exact same thing that the 84 people have. You are going to, once again, quit out, hit second stat, go over to math, do number 5, tell it sum of list 3. You should get 18, which they got. Excuse me. Sorry, my allergies bother me. And then go to second vars. And then go to number 8. This is for your p-value. And then you're going to type in your test value. Infinity. I just hit 1 with a whole bunch of zeros. That's fine. And then paste. And then that gives you your p-value. Like I said, 84 people, everything's done for you. When you run the Goff test, you get 18 and your p-value. All right, so 83 people. Let me go back to the first page. Sorry, 84 people are kind of just waiting around. Okay, if you go to the bottom, here is the red, all right here. In this big red box here is 83, is everything you need for the 83. You have list 1 minus list 2 squared divided by list 2, sum it. Right where you get sum, you go to second, stat, arrow over to math if you can't remember where the sum function is, and it's number 5 on that list. So second stat, arrow over to math, and it's number 5. This is under second VARs, and this is the chi-square CDF, and I think it was number 8 on there. All right, so let's do our sentences now. We're all done. All right, so we need to write a p-value down. P-value was 0.012. Oh, 0012, I think. Check. Yep, 0012. Sorry about that. All right, so let's talk about this. Nothing changes when you do a hypothesis test. It's always the same. So if I look at this 18, my shading starts at 9.49. So does this land in shaded? Lands in shaded, you reject. Is P low? If P is low, you reject the hoe. So P is lower than the alpha level. The alpha level was 5. So since it's less than 0.05, we reject. So either way, we reject. All right, so we're going to write 2 sentences here. All right, p-value sentence. This is the same p-value sentence for the whole chapter. There is a 0.12% chance. I changed the p-value to a percent chance of getting the same observed counts, because that's my sample now, or more extreme. And then we say based on the expected counts. Because your hoe is based off of your expected counts. In the last chapter, we said based on the hoe. Well, the hoe is the expected counts. The hoe up here said they were evenly distributed or there was no preference. And the expected counts are basically just the numbers representing the hoe. So that is going to be every single time, everything in this chapter. That is your, excuse me, your p-value. Okay, that is your p-value sentence. So all you have to do each time is just change this percent. All right, so we said reject. 2 reasons why we reject. 18 lands in shaded. P is low, reject the hoe. So we say reject. Okay, this is the tricky part. You are rejecting the hoe. The hoe says no preference. So if you're rejecting no preference, that means there is a preference. So it's always kind of based on the ha in this chapter because they're exact opposites because we don't have numbers. Okay, so if your hoe said they were evenly distributed and you're rejecting that, then you're saying they're not evenly distributed, which is the ha. They're opposites in this chapter. So if you reject, you have evidence for the ha. Okay, so reject. There is evidence to suggest that the flavors that, let's say, there is a preference in flavors if you did it that way. Or that the flavors, you don't have to do both, just pick one. Flavors are not evenly distributed. Okay, done with 1. Example number 2. This one will go faster. Okay, so it says the following data were obtained from a random sample of absences for a given company. At the alpha 5% level of significance, test the claim they occur with equal frequency. So here we go. So let's do our hoe. So we're saying that the number of absences for the company should be evenly distributed or equal frequency. So hoe. The absences occur with equal, use your problem to make your hoe, with equal frequency. Or you can say the absences, you don't have to do both, are evenly distributed throughout the week I'm giving you 3 different hoes. Or you could say there, remember I said ho goes with no, or there is no preference for a certain, this is harder to write, day of the week to be absent. Okay, I gave you 3 hoes there. Okay, then whatever ho you want to do, your ha is going to be the opposite. I'm just going to use my first one. The absences do not occur with equal frequency. Okay, if you want to do this one, you say the absences are not evenly distributed, or you say there is a preference. All right, so I'm not going to write a whole sentence, but oops. I'm not going to write a whole sentence, but I'll put it in. So if you said the second one, you would say absences are not evenly distributed. Or if you said there is no preference, you would say preference in day of week or absence. Okay, so you have 3 choices on this one on how you want to set up your ho and ha. It doesn't matter to me. All right, so let's now go to our critical value. I'm going to draw our curve. Right scale, remember, no negatives in this chapter. Right scale, right tail, sorry. The alpha level on this one was 5%. So you're going to go across the top to 5%. The degrees of freedom was also 4 on this one because there's 5 days a week minus 1. So the degrees of freedom was also 4. So it's exactly the same as the last one, but you get the chi-square chart, right? You just go across the top to your alpha and then go down, and then that's where your critical value is. Right, so it's also 9.49 on this one. Right, now, ready? We're going to put them in our lists. Well, let's calculate our expected value first. Okay, so if you look at this, this totals to 109. If you just total up list 1, it totals to 109. So these are your observed. I'm going to put that in list 1. Your expected, we're going to put in list 2. So we're basically going to evenly distribute them. So we're going to do 109 divided by 5 again. So because there's 5 days in the week. When you do that, you get 21.8 for each of these. Leave it as a decimal. These expecteds are a theoretical number. So don't round them. It'll throw your problem off. So leave those as 21.8. So graphing calculator, everybody's going to go into stat, edit. I need to clear my list from my other problem. Okay, so in list 1, you're going to put your observed, which I've kind of cheated and already had them in list 5. That's what those numbers were there for. So I keep thinking this is a touch screen, sorry. Okay, so my observed are in list 1. In list 2, I'm going to put my expected. I got that by totaling up list 1, which is 109, and dividing by 5. So I'm going to put 21.8. Oh, shoot. In each of my things here. All right, 84 people, you're good to go. Stat test, Goff test, and it does everything for you. you can ignore this part. 83 people. Here we go. Up at the top of list 3, you are going to do list 1. Oop. L1 minus L2 parentheses squared divided by L2. So the formula, O, observed is in list 1, minus E, expect is in list 2, parentheses squared, divided by list 2. 84 people, you can ignore all of this. Hit enter, and you get that. Those are what you're going to write down for your work. So you're going to write the first 2 and the last one. So you may want to do that right now. So on your paper, write 1.76 plus 0.35 plus ... 0.47. Quit out. Let's see what that sum is. Second stat, math, sum, list 3. There is my test value, 4.71. Now for the p-value, second vars. Chi-square CDF, test value is 4.71. Leave that as infinity, and the degrees of freedom was 4. If you need to watch that again, you can rewatch that again. Hit enter, and there is your p-value. Okay, 84 people. So 83 people you can start writing down. You write your first 2 and your last one of list 3. The sum of list 3 is the test value, so it's 4.72. And then the p-value was 0.318. 84 people. Yours is super easy. You just put it in list 1, list 2. Go into the GOF. You don't have to change anything for this problem because the degrees of freedom was even the same. There's your test value. There's your p-value, 0.318. It's a little off. Yours is actually more accurate than when they're doing it because they're doing it by hand. So you're going to copy down this. Just use your right arrow. So 1.76 plus 0.36 plus ... There's the third one. There's the fourth one. There's the fifth one, 0.47. All right, everybody, here we go. Let's do the work. Okay. So whether you're either getting this from the bracket, 84 people, you can get it from the bracket. 83 people, it is your list 3. So 1.76 plus the second one was 0.3. I think it was 7. I'm going off of memory. Plus ... And then the last one was 0.47 equals 4.7172. It depends on a rounding and how many places you took it out. So 4.72. The p-value for this problem was 0.318. Okay, so this 4.72 lands in white. Don't reject. This is much greater than 5%. So P is not low. So don't reject. Okay, text box and our sentences. Okay, p-value sentence. There is a 31.8% chance of getting the same observed counts or more extreme. Same sentence throughout the whole chapter, based on the expected counts. Okay, fail to reject. There is no evidence to suggest. Okay, now this is a little tricky. This whole chapter is in terms of like the this last sentence. So We have no evidence to reject. So we have no evidence to say any of these things. It's always in terms of the ha. Okay, so always do your sentence, your rejection sentence in terms of the ha. So there is no evidence to suggest, and then whichever one you picked, write these. So to suggest that the absences occur with, that the absences, do not occur with equal frequency. We have no evidence, because it wasn't different enough, to say that absences are different for each day. So your fail to reject is there's no evidence to suggest that the absences do not occur with equal frequency, or they're not evenly distributed, or there is a preference in the day of the week. You don't have enough. Was there differences in the days? Yes, but was it enough? No, you didn't land in shaded. You only got a difference total of 4.72. Okay. All right, so you have a couple problems for homework to do on that, and then we're going to pick up in the next video with the other type, where these are not going to all be the same number. They're based off of a percentage. So we'll pick that back up in the next video. So you can do the first page of homework.